Hi, I'm Seth, and I'm going to teach you periodic trends of ionization energy and electronegativity. Let's start with the definition of ionization energy. It is the minimum amount of energy required to remove an electron from the ground state of an atom. The greater the ionization energy, the more difficult it would be to remove the electron. So groups 1 and 2 on the left side of the periodic table are much easier to remove than uh, the nonmetals on the right hand side of the periodic table, which generally are much harder to remove an electron. Ionization energy increases as successive electrons are removed. So you can have a first ionization, a second ionization, a third ionization, a fourth, so on. So first ionization might be low, second gets higher, and third even higher. And that's because the electrons are being pulled away from a more positive ion. So as you continue to remove electrons, and they require even more energy. A few things you want to know. Ionization energy decreases down the periodic table. So like down the columns. And ionization energy uh, decreases. So like the bottom left of the periodic table is where it is the easiest to remove an electron from an element. Ionization energy increases across the periodic table. So metals have a low ionization energy. Group 1 and 2 and nonmetals have a high ionization. And no, sorry. Metals have a low ionization energy. Group 1 and 2. And nonmetals have a high ionization energy, like noble gases, which are not interested in giving away their electrons. Another period trend is electronegativity. Electronegativity is the attraction of electrons. So if you have a high electronegativity, that means you really want electrons. And if you have a low electron negativity, that means you are easily giving them away. You want to give them away. So for this, we know like lithium. Lithium wants to get rid of its electrons, and so we know it has a low electronegativity. And nitrogen, we know, has wants to get electrons. It wants to get 3 electrons to be exact. So that would have a higher electronegativity than, say, like lithium. Let's compare nitrogen and fluorine, though. They both want electrons. Nitrogen wants 3 electrons, and fluorine wants, wait, let's say 1 electron. Which one has the higher electronegativity? Fluorine has a higher electronegativity because as you move across the periodic table, electronegativity increases. Um, so we know that. But if we compared sodium and lithium together, they both want to give off. They want to like give off their electron. So which one has a higher there? Lithium would have a higher electronegativity because as the periodic trend goes, it goes up because and the reason it goes up the periodic table is because shielding. Shielding is when electrons on the outer shells propel the electron away from the atom, and it almost like blocks the nucleus, which is positively charged, and that's what shielding is all about. So electronegativity increases as it goes up.